Today I am going to discuss about fluid mechanics. What is the rate of flow? Rate of flow of liquid. Consider a pipeline, isn't it, with the surface S with velocity v, then flow of rate this is denoted by q is equal to volume upon time, isn't it? Therefore q is equal to volume is area of the surface into velocity of the liquid into time. Upon time, it means a into v, small v, volume velocity, into t upon t. T cancelled, there so should be flow of rate is equal to area into velocity, a into v. This is the phenomena of rate of the flow in a uniform pipeline with some velocity is v and the surface is s. This is our rate of flow. Now we are going to discuss about what is the Reynolds number. It is a very important topic in fluid mechanics. This is Reynolds number. Basically, Reynolds number shows the what is the type of the liquid will be flow in the consider pot or container or a pipeline, whatever you can say. Reynolds number shows the characteristic of the fluid. Whether it is streamline flow, whether it is turbulent flow, whether it is an unstable flow. There are three conditions. Basically, is streamline flow. Streamline flow. Earlier I had to discuss about that. Streamline flow is a steady state flow. Steady state means it maintains the continuity of the flow. It maintains the time periods. Maintain the each and every path where the flow of liquid will passes through in any pipeline. There are three characteristics. The formula will be used is Rn. Rn means Reynolds number is equal to rho into V into capital D upon eta. This formula is used to find the value of Reynolds number. Whether rho is denoted the density of liquid, V is the velocity of liquid, D is the diameter of pipe, and eta is coefficient of viscosity. Now the characteristic. If any questions, these values are given, put the value and solve the number of this. But how we will find? First, if Rn is less than value of 2000, If Rn is less than 2000, it shows this flow of liquid is in steady state mode or a streamline. It is a streamline. Clear? Now, second one is if Rn is greater than 3000. If Rn is greater than 3000, then it shows it is a turbulent flow. Turbulent flow. Okay. Turbulent flow matlab it is a disorder of the liquid, disorder of the flow of liquid in any pipeline. Disorder means it's not a path in a continuity, it's not with a time of period with the flowing of rate will be considerations. This shows the disorder or turbulent type of flow. If the value of Reynolds number is greater than 3000, it goes in the turbulent flow. If less than 2000, it goes in the streamline or steady state conditions. And third one is between 2000 to 3000. If the value of Reynolds number lies between 2000 to 3000, it goes as in unstable. Unstable. Unstable means, one thing is very important. Unstable means if the value of Reynolds number is lies between 2000 to 3000. Unstable means basically unstable shows it maintains the continuity of the flow of liquid but varying with the time. It's varying with the time. This called as unstable. If the continuity will be changed and same as time will be changed, this is a disorder. And both are the equal, this is a streamline. There are the characteristic of flow of liquid or fluid in a container or a pipeline. This is the Reynolds number. It is a very important thing. How can we find? This is rho V by theta. We find the Rn value and taken that whether it will be lies between these things. You consider that this is the streamline flow, this is the turbulent flow, this is the unstable flow. Now the continuity equation. Go and solve the questions. Continuity equation. Continuity equation. This is area A1, this is area A. If a point this is A, this is B. Okay. Density of this is rho1 and density of that is rho2. If it is streamline condition, whether in case of continuity equation we have to find that mass of A point is equal to mass of B point in equilibrium state, then mass is equal to volume into density. Therefore this should be A1 B1. Volume is equal to, in a case of rate of flow, I have to discuss that. Volume is equal to A1 B1 and density is ρ1 is equal to A2 B2 and density is ρ. This is our equation of continuity, whether in a same path, same continuity, streamline conditions within uniform, different point, different velocity, but it maintains the continuity. Therefore, we find the equation A1 B1 or 1 is equal to A2 B2, where A1 is the area at point A, B1 is velocity at point A, and ρ1 is density at point A. Whether A2 is the area at point B, B2 is the velocity at point B, and ρ2 is the density at point B. In the competitions or whether you are going to give the examination, we can use this formula. If the ρ1 and ρ2 is the same, for any consider the case of the point A is the water and point B is same as water, we cancel out this ρ1 and ρ2. Just use this formula. A1 B1 is equal to A2 B2. We have to find the answers of this A1 or velocities, yani area or velocity.